Hello class, welcome to another day. We're actually starting a new chapter today. It is chapter 5, which is called polynomials. Poly meaning many, and nomials meaning terms, so many terms. And in today's lesson, 5.1, we're going to be doing multiplying and dividing monomials. Monomial, mono meaning one, and then monomials meaning terms, so one term. I believe this lesson is a review for all of you in here. We're going to be studying two things especially, multiplying and dividing. And there's a couple different things that I want to remind you of. So we're going to do that today using actual numbers first, and then we will get into our exponents with our variables. So, just to get us thinking about this lesson, if we had 2 squared multiplied by 2 cubed, the way you did this back in the 5th, 6th grade was you said 2 squared is the number 4, and 2 cubed is the number 2 times 2 times 2, which is 8. So we have 4 times 8, which is 32. And there is our answer. 2 squared times 2 cubed is 32. And then you guys realized that there is the product property of monomials. The product property states if you have the exact same base, which as you can see we have a base of 2 and a base of 2, if you have the exact same base, you can add their exponents. Such as, we have 2 squared multiplied by 2 cubed. The bases are the same, so we can add their exponents to make 2 raised to the 5th power. 2 plus 3 is 2. And if you go in your calculator and you raise 2 to the 5th, or just do it in your head, 2 times 2 times 2 times 2 times 2, that number is 32. So this is beneficial when we have variables with exponents on them. Here's the process that we use. The coefficients we actually multiply by each other. So the 3 times the negative 4, we multiply those. 3 times the negative 4 is the number negative 12. Now the exponents, that's where we use the product property. We're multiplying, so when we have the product property for exponents, we add them. X cubed times x squared is x raised to the 5th. And then we have y squared times y to the 4th, as long as they have common bases, which as you can see, y as a base and y as a base is y to the 6th. So our answer when we multiply 3x cubed y squared multiplied by a negative 4x squared y to the 4th, we get a negative 12 x to the 5th, y to the 6th. And we have successfully simplified that monomial by multiplying. Now, as we move onward, we have a power raised to a power, or what is called an exponent raised to another exponent. So when this is the case, you learn the power property for exponents. We'll use that, or we'll show that using actual numbers again. Let's say we had 2 squared and that number raised to the 3rd power. 2 squared raised to the 3rd. Well, we'll simplify this first by doing the parentheses. So 2 squared is 4, and then 4 cubed. You can do that in your calculator, or if you can, do that in your head. 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. So when we have 2 squared raised to the 3rd power, we get the number 64. Now, back in intermediate algebra, you also learned that we can use the product property of exponents. That states this: 2 squared raised to the 3rd. If we have an exponent raised to an exponent, which is exactly what we have right here, we can multiply those two together to get that same base of 2 raised to the product of 2 times 3, which is 6. So 2 to the 6, you can do that in your calculator, or do it in your head. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. So we get our answer of 64 when we use the power property. That is when we have an exponent raised to another exponent, which means we would multiply the exponents together. Now, using that information, we're going to apply that to monomials. So once again, our coefficient, we're going to do what's actually written. We're going to say it is a negative 2 raised to the 5th power. So a negative 2 times a negative 2 is a positive 4. positive 4 times a negative 2 is a negative 8. A negative 8 times a negative 2 is a positive 16, and a positive 16 times a negative 2 is a negative 32. If you don't want to do that in your head and you want to use your calculator, that is just fine with me. But a negative 2 raised to the 5th is a negative 32. Now we have p cubed raised to the 5th. When we have an exponent raised to an exponent, we multiply to get p raised to the 15th power. And then we have s squared raised to the 5th, which means we would multiply those two and get s raised to the 10th. Our answer, when we simplify, is a negative 32, p to the 15th, s to the 10th. Moving on to the next one, why don't you guys try this, pause the video, and then you guys can check your answer with mine after you do it on your own. So we have 3 squared, that is 9, and then x raised to the negative 3rd squared. We would multiply those two together and get x raised to the negative 6th. Now, one property of exponents that you guys might remember is that you can never, ever, ever, ever have a negative exponent in your answer. That is mathematically incorrect. So what we do with that is we learn that whenever we have a negative exponent, we can move it from the denominator to the numerator and change the sign, or move it from the numerator to the denominator and change the sign. So in this one, our x raised to the negative 6th is in the numerator. It is over a denominator of 1. So if this is the case, if my base has a negative exponent, I can simply move this to the denominator and change the sign on my exponent, making my answer 9 over x raised to now the positive 6th. And this becomes my answer. So remember, whenever you have a negative exponent, you could simply move that exponent and the base from either the numerator to the denominator or the denominator to the numerator, and all you have to do is change the sign. Always make your exponents positive. Working on this next one, we have x raised to the negative 3rd times x raised to the negative 4th. If you guys kind of can picture what's happening right now, you can move this to the denominator right away, but that might be more inefficient, because what's a negative number times a negative number? Rats, I made a mistake. I thought I was doing the power property, but I'm doing the product property. So here's what we got. We have x raised to the negative 3rd times x raised to the negative 4th. When we have multiplication, we add their exponents. Common bases of x and x. If that's the case, all we have to do is just add their coefficients. So we have x raised to the negative 7th, because a negative 3 plus a negative 4 is a negative 7. And then we learned on the last one that we can never have a negative exponent in our answer. So we're just going to move this to the denominator, making the number 1 in the numerator over x raised to the positive 7th in the denominator. And this is my answer. And the last one that we're going to do for multiplying today, number 5, 5x raised to the negative 2nd multiplied by a negative 2x raised to the negative 4th. Their coefficients, we actually multiply these two together, so we multiply 5 times a negative 2 and get a negative 10. And then we have x to the negative 2nd times x to the negative 4th with common bases, which we have a base of x and a base of x. All we do is we add their coefficients. A negative 2 plus a negative 4 is x raised to the negative 6th. This would be my answer if I had positive exponents. However, I do not, so I have to go through one more step. I'm going to keep the negative 10 in the numerator, and the x raised to the positive 6th is now going to be in my denominator. And that is my answer for number 5. This concludes the first 5 problems on multiplying monomials.